Okay, we're looking at a new style of proof that you might have heard or we might have touched upon before, which is induction. And there are three types, and we'll just do each one in a new video. And the first type is what I think is the easiest type, which is the sums. Now, when you're having sums, you're adding terms. So, for instance, people before us have gone ahead and worked out all these neat little tricks when you add numbers. Now, it might be 1 plus 2 plus 3, or it might be some other sequence. But people have already worked out there's a formula for adding terms. So you don't have to worry about where these formulas come from. But the formula, the pattern will be given to you. So for instance, 2 plus 4 plus 6 plus 8 plus 10. And the last term, so this is the term 2n. Like for instance, when you had the first term T1 is 2, T2 is 4, and the last term we just called 2 times n because it's not n, it's twice some number. Okay, so we can't prove things by just using examples. We have to have a formal set of steps, and I'll be showing you on the next slide. But the things that you have to look at are notation. So n that we're using here and here and here, that's the number of the term. So the first term, the second term. Okay, so n equals 1 is the first term. But we have to look at general terms to prove things, and so we use these letters k. And so n equals k is the kth term. And it might be the 100th term or it might be the 500th term. You don't worry about it. It's just the kth term. And then we look at the very next term, and you'll understand why when we get to the next slide. But n equals k plus 1 is the next term after the kth term. So like for instance, if this was the 51st term, which it's not, then this would be the 52nd term. It's the next term after it. And the other two things we have to look at are S, the letter S for sum, because we're looking at sums because we're adding numbers together. So the abbreviations we look at are SK, which is the sum of k terms. So it might be the sum of 5 terms, but it's not. It's the sum of k terms. And then the next thing we have to look at is the sum of k plus 1 terms. So whatever the first number is, it's the next number. So that's the abbreviation we're going to use. So copy that and come across when you're ready. Okay, so here are the 3 steps. And you just have to follow these steps. You prove it's true for n equals 1. And this is just done by substituting into the formulas, which you'll see in a sec. So step 1 is easy. Step 2 is the start of the mathematics. And what we do is we assume it's true for n equals k. And this is actually the easiest part of the proof. Like step 1 is easy, but step 2 is even easier. Okay, so they're the gimme steps. But step 3 is the maths. And what we have to prove for any formula, we have to prove that the sum of k plus 1 terms minus the sum of k terms is the term that we added. Okay, so like for instance, if we've got, again, we're not using particular numbers, but if we have S5 minus S4, the difference between those must be the term that you added to go from S4 to S5. So if we can prove for not numbers 4s and 5s, for any term k and k plus 1, that the difference between them is the term that you've just added. So okay, the term added to go from sk to sk plus 1. Okay, so that's the term we added. And this is the hardest part, but in actual fact, it's some pretty simple algebra. So copy those down, and when you're ready, come across. Okay, so what we're going to look at are the steps for the example that we did. So step 1 is n equals 1. I'll change colours just so it stands out. So n equals 1, the left-hand side equals 2. So, okay, so here's the equal sign. So that's the left-hand side. That's the right-hand side. So the left-hand side is the first number 2. And the right-hand side is, this is the formula. So we say 1 times 1 plus 1 equals 1 times 2 equals 2. So we've got the left hand equals the right hand. So therefore, it's true for the first number, n equals 1. Now, step 2, I told you it's easy. All we do is we say it's assume it's true for n equals k. And so we say sk. So this is the formula for the sum. So we just say sk equals k bracket k plus 1. So we just replace the n on the right-hand side with the letter k. Okay, so this is now we're up to the hard part. So we have to try to, this is what we're trying to prove. And that's always the same for all of these questions. And so what we've got is we've got sk from step 2, and we've just got to find these 2 values here. Okay, so I haven't got a page extender, so I'll just squeeze it over here. So sk plus 1 is this formula with the letter k for where n is. So we got, okay, there's your n value, what used to be the k, what used to be n is now k plus 1, and then I've got k plus 1, which is the n value here, and then it says add 1. So I've got k plus 1, k plus 2, and then I expand that out using just your normal brackets, so end up with 3k plus 2. Okay. Just to make it really clear, tk plus 1, which is this part of the formula, is just that number there at the end of the sequence where n is, and just put k plus 1. So it says 2k plus 1, which equals 2k plus 2. Okay. So what we have to do, I don't think I can, can't get down any further. Okay, so what I'm going to do is I'm just going to squeeze that, if I can do that. Okay, so this is what I'm trying to prove. So we've got pen back again, purple. So sk plus 1 minus sk equals tk plus 1. tk plus 1. So the left-hand side equals that number, k squared plus 3k plus 2, minus sk, which is that number just there. Now I didn't expand that out, but k times k is k squared, k times 1 is k, so k squared plus k. So k squared minus k squared is nothing, 3k minus k is 2k, 2 minus nothing is 2, and then you say, equals tk plus 1, therefore true for all values of n. Okay, so this will always work. They give you the formulas, someone always done the hard work, the formulas always work, you just have to plug it into that formula. Okay, so let's have a look and see if I've got any more examples. Okay, so in this next one, there's another way that the question could be written, but it's still going to be a sum. Okay, it's just another way of doing it. So what they've got is this Greek letter, looks like an E, but that Greek letter is actually sigma, and in maths, sigma means the sum. Okay, so what they do at the bottom is they tell you where the first term will start from. So it starts from r equals 1 and it goes up to n, and I'll show you what this means in a sec. And that's the number we're going to put it in, and then that's the formula that is the results. Okay, so what does that all mean? Okay, so come across and we'll have a look. So r equals 1 means you start from 1 and you're going up to n, so it's going up in ones because it just says r. Like if that had said 2r, then it'd go up in 2s. If that had said 2r plus 1, then you just put it into the formula. But this is just going up, it just says r, so it's going up in 1, 2, 3, so it's going up in ones, up to that number, and that's the formula. Okay, so once you've got it in that form, then you just do your step 1, step 2, step 3, and the answer will work out. Okay, that's it, and there'll be practice on Moodle. Bye.